Welcome to my YouTube channel, and today we will discuss about the decision tree for regression problem. Let's consider we have some data like this where we have experience and if there is any gap in the career and the salary. In this case, these are our input features and salary is our output feature, and which is a continuous variable. So this is actually our continuous continuous output. That's why this is kind of a regression problem, because when any new data will come, we have to predict that okay, what will be the salary, and it can be 57, 56, anything. Okay, so you understand, I think the problem statement is clear, because as of now we discussed about the classification problem using the decision tree. So the interesting thing is, let me just, so interesting part here is because it's a regression problem. So you have to remember this thing, that in this case, we cannot use entropy or Gini impurity. We cannot use. So let me just erase this part. Okay, so just remember this thing. We cannot use entropy in this. So here we'll cover basically two things. One is how to use continuous variable in this feature, because in this case we have this continuous feature. So how we will use this continuous feature? So one thing we will learn, that how to use continuous variables as a feature. And second thing, we will learn how to use this, how to use the continuous variable as target or output variable. So two things we'll try to cover. Okay, so first thing first, remember, just in this case you have to sort the data. So in our case already experience is in a sorted order, so remember this thing. That's kind of our first step. And then what we will do, we will just start from the very beginning. We'll first assume that okay, we have to start our split using the experience and using this first value. Okay, so if we do that, then what will happen, how our tree will look like? Our tree will look like something like this: less than equal to less than equal to 2. And in that case, if you do a split, so our tree will look like something like this. So first of all, here we have all the values, so 40, 42, 52, 60, 56, all the values are here. And when we'll split, less than equal to 2 mean only 40 will come here, and remaining everything like 42, 52, 60 and 56, all these observations will come here. Okay, again on the other hand, like let's consider, because after this we have to find out the information gain. So in this case, information gain, how we'll calculate that I will show you. Okay, and let's consider that if we now check 2.5, then what will happen here, we will have 40 and 42, whereas here we will have only 52, 60 and 56. Hope up to this you understand, right? We will try with this, and then we'll select okay, which one is the better choice. And how we'll do it, That is by we can do, which is called variance reduction. So variance reduction. This is the part we will learn in today's class more thoroughly. Okay. Okay. So now let's consider what is the variance actually. First we'll learn about the variance. Variance. And what is that formula? The formula is 1 by n 1 to n y minus y mean square. So first we have to calculate the root node variance. So let's capture the root node variance. Okay, and if we have to calculate the y mean, then what will happen? What is the y mean? Y mean is basically nothing but 40 plus 42 plus 52 plus 60 plus 56 divided by 5, which will come to 50. Okay, so then variance of root node will be 1 by n summation of 1 to n yi minus 50. And if you do this calculation, what will happen? You will basically get something like this: 40 minus 50 square plus 42 minus 50 square plus 52 minus 50 square, this is 52, and like this, and ultimately your total will come 60.8. okay, if you do this calculation. So this is, I have already done this calculation, that's why I'm not showing, because I just gave you the mathematical intuition, like how we are doing these things. Okay, I think up to this it's clear. So that's the way you are calculating the variance of the root node. Okay, it's a very important thing. Okay, and when variance of a root node, when it is less than equal to 2, remember this thing. So basically we are calculating here, so this situation. Okay, now what we have to do, we have to do the same calculation for variance of the child. So in this case these two are the child, so we have to basically now calculate the variance of the child, c1. Let's consider this is my c1 and this is my c2, so that you can understand, and that's basically my root node. Okay, so variance of the child, what will happen in this case? Again, 1 by n. So n is in this case 1 because we have only one value, and then 40 minus 50 whole square, so it will come as 100. And now the variance of child c2, it will be 1 by 4, and then if you just follow the same kind of logic, that's mean 42 minus 50 whole square plus like this, it will be 1 by 4, so 64 plus 4 plus 100 plus 36, and then this will come as 51. So we calculated all the variance. Now what we'll do, we'll do the variance reduction calculation. Variance reduction. Okay, so this is the way you have to calculate. Like based on that, you will take a final decision. So variance reduction is variance of the root node minus the weight I and then the variance of the child. This is the formula of the variance reduction. So variance of the root node, we know it's a 60.8. We already calculated this thing. Now, what is this weight part? This weight part is nothing but how many observations are on that child actually. So in the first C1 case, like if we again consider back here, we have only one observation, so it's 1 by 5. So 5 is the total observation. So total observation is 5, 1, 2, 3, 4, 5. So 1 by 5 into what is the value of C1 is 100, right? So we will mention here 100, and again here it will be 4 by 5 into 51. Okay, so ultimately my total will come basically, if you do it, 60.8 minus 20 minus 40.8, which will make it 0. Oops, 0. Okay, so this is the interesting thing. So first, whatever the way we split, we found our variance reduction is 0. Okay, now if you do the same thing, so now let's do the same thing for the another thing. Like that's mean we'll do the same exact calculation but on the different split. Different split mean when we have less than equal to 2.5, and then we have 40 and 42 in this child node, and in this case this is the root node, and in this case we have 52, 60 and 56. So we'll do the calculation again, and in this case what will happen, variance of C1 will come 82 and variance of C2 will come 46.67. I'm not showing all these things, but this is the way it will come if you just put it into the formula. So let me just probably just show how we calculated the variance of C1 in this case. So what is the formula? Again 1 by n, so in this case 1 by 2, and then what is the mean? So 40 minus 50 whole square plus 42 minus 50 whole square. So that's mean 1 by 2, basically 100 plus 64. So 164 divided by 2, which is 82. So that's why I mentioned this one. Okay, so now the variance reduction of this thing will be, what is that? VR, which is my root node. So this is equal to minus summation of weight I and the variable of the child. So what ultimately it will come? It will come 60.8 minus, again now this calculation, 1 by 2, sorry 2 by 5, because why 2 by 5? Let's understand why 2 by 5, because I have only 2 observations here out of total 5 observations, into, what is my value for this one? 82 plus 3 by 5, this is my weight, into, this is 46.67, and ultimately it will come 0.304. So the thing is, whatever variance reduction is giving me the maximum, select that split. So what is the important decision? So first we calculated all these things, but then what is the important decision you're capturing? The important decision is whichever variance reduction whichever variance reduction is giving max value, select that split. So that's select that split. So in our case, that's mean what we will do, we will select this split compared to other one. So that's a very important thing. Okay, so that's the way we have to select the split. Okay, now the another interesting question is then, okay, when the new test data will come, how we will calculate. So let's consider, okay, now we know that, okay, we have to select this, which is less than equal to 2.5, and we have the data something like this. Let's consider 52, 60, and 56. Okay, so when the new data will come, so new test data will come here, and it will suppose follow this path or maybe this path. So whatever path it follow, it will calculate the average, and that will be the prediction. That will be the prediction. That will be the prediction. So by chance, if the data is going into this path, that's mean our prediction will be 40 plus 42 divided by 2. By chance, if it is going into this path, then our prediction will be 52, 60 plus 56 divided by 3. So that's the way the final regression value will get calculated. So in this session, we learned two important things. Okay, what are the two important things we learned? We learned how to use, so first of all, we learned this one, that how to use the continuation of, sorry, we learned basically two things: how to use the continuous variable as a feature. So this is one thing, and how the continuous variable is a target. So the last thing, the whatever the variance reduction part we described, that is related to this one. Whatever the variance reduction part we described, that is related to this one. And when we are calculating the average part, that is related to this one. So let me just quickly summarize one more time so that it will be handy. So when we are working with the continuous variable, so when we are working with the continuous variable, we do not go to entropy. We calculate the variance reduction of the split, and we select the max. We select that one, the max variance reduction, like the max information gain. We select the max variance reduction, and when it is coming to the continuous variable output variable, then we calculate the average value for the final result. Okay, hope this makes sense. So remember these two terms: variance reduction and formula for calculating the variance. So let me probably write it down one more time so that it will be handy, because just two things we have to remember. One thing is basically what is the formula for variance. So let's see one more time. Variance formula is 1 by n summation of I equal to 1 by n y I and y mean square. So that's the way we'll calculate the variance of each node. Okay, we'll calculate the variance for the root node, we'll calculate variance for the child node and everything. So that's the way we will calculate this thing. Oops. Okay, and then we will do the final formula for variance reduction. So what is called variance reduction formula. This is also, remember this formula because this is important. So variance reduction formula is variance of the root node minus weight and then variance of the child node. Okay, remember this part. This is very crucial to find the variance reduction and the variance calculation. Okay, thank you. I know it's got little lengthy, but try to understand this concept because this will give you the in-depth intuition of the mathematical part of decision tree when you are solving the regression problem, and you will get a good understanding. We will show the practical examples in the next video. Thank you so much. Please give a thumbs up or like, subscribe. Um, Thank you. Have a nice day.